This is Engage New York, Module 3, Lesson 15, Problem Set, Debrief. But this is really concept development and problem set all at the same time. So Lesson 15 and Lesson 16 are preparing you for the end of the module test. And the end of the module test is going to be all word problems. And the word problems are really designed to see if you can apply what you've learned about adding and subtracting fractions, even with mixed numbers, sufficiently. Is this skill established in your brain? So we are going to use the RDW strategy, which means read, draw, write. Now, they've only given you about this much area because it says show all your work. I don't think I can solve this problem in just that amount of space. So what I'm going to do is I'm going to use line paper to do all the solving, because I have to read it and then I have to draw it and then I'm going to write out my strategy and solve. So let's go ahead and first let's read the problem to get started. So in a race, the second place finisher crossed the finish line 1 1/3 minutes after the first place finisher. The third place finisher was 1 3/4 minutes behind the second place finisher. The third place finisher took 34 2/3 minutes. How long did the first place finisher take? So let's go back and let's just talk about the problem. So number one, the first sentence tells me that the second place finisher took 1 1/3 minutes longer than the winner. So I'm going to go ahead and I'm going to get my paper. So here is my line paper that I'm going to go off of, problem 1. So here is the first place finisher, and we don't know the time on the first place finisher. That is the question. But what we do know is that the second place finisher took 1 1/3 minutes longer. So I'm going to say plus 1 1/3 minutes is the second place finisher. Now, so the second sentence tells the third finisher took. Now, then the second sentence is the third place finisher took 1 3/4 minutes behind the second place finisher. So now we have to add the third place finisher, right? So the second sentence says the third finisher took 13 minutes longer than the second finisher. So I'm going to draw a bar. I just draw the bar for the third finisher, and I'm going to label the difference . 1 3/4 minutes. And the third sentence tells us the third place finisher's minutes altogether. So altogether, the third place finisher took 34 2/3 minutes altogether. Whoops. So this is what we know. So we read the problem, now we're drawing. So we know the third finisher's time, but we don't know the second finisher's time. So how are we gonna add all this up? Or are we gonna start taking what we know and moving backward to try to find the correct times? And so instead of moving forward and adding everything up to get this total, we now have to move backward to try to find the total. So instead of adding, what operation are we going to use? That's right, we're going to subtract. So we know the third finisher's time, but we don't know the second finisher's time. We're going to solve it by what? Yes, subtracting. So let's start out by using the third finisher's time, 3 2/3 minutes, and we're going to subtract it from 1 3/4 time, because when we subtract it from here, what time are we going to find? We're going to actually find the second place finisher's time. So let's subtract it from 1 3/4 minutes. So let's go ahead and let's pull out the whole numbers. So 34, subtract 1, and then we're going to have 2/3, subtract 3/4. So now we need to come up with a common denominator. And we're going to end up with 33. And then we're going to have 4 times 2 is 8. Hold on. You can't see my paper, so let me move it. Okay, so I found my common denominator, and I changed my fraction. So I have 33, and then I have 8 subtract 9. Can I take 9 away from 8? No, I cannot. So I'm going to need to borrow. So yes, you're going to be doing a lot of this. And you're going to add 12 over 12 here, right? So we're going to end up with 32. And you have to add, in order to add two fractions, they have to have common denominators, right? In order to add this one whole over here so that I can subtract that 9. So 8 plus 12 is 20. 20, subtract 9 over 12. Now I can do that. And I'm going to end up with 32 and 11/12. So what does 32 and 11/12 even mean? Well, it's a second place finisher's time, right? Now we know the second place finisher's time. Do you see why now I'm not using this little bitty space? I'm already taking up half a page here. All right. So we now found the second place finisher's time. Now let's find the winner's time. So what's that subtraction sentence going to be? So now we have the second place finisher's time. It is 33 and 11/12 minutes. That's what we just solved for. Now we're moving back again, and we now need to find the first place finisher's time. So what's our subtraction sentence going to be now? Well, it's going to be 32 and 11/12, right? Whoops. I think I just wrote that wrong. 32 and 11/12. So we have 32 and 11/12, and we're going to subtract 1 1/3. So now we're trying to solve for that first place finisher time. Okay. All right, so here we go. Now, what do we do? What do we have to do in order to make this work? Well, 32 subtract 1, 11/12 subtract 1/3. How do we subtract two fractions? Well, we have to create that common denominator, right? So now 32 subtract 1 is 31. And we have 11 minus 4 over 12, right? So we have 31 and 7/12. So we have 31 and 7/12 minutes. So now we have 31 and 7/12 minutes. 31 and 7/12 minutes. Now, the winner's time is 31 and 7/12 minutes. Now, question. How do I convert 31 and 7/12 minutes to minutes and seconds. So what are you going to do? This is one of those things that you have to start thinking. How do I turn this into seconds? So I need to convert 7/12 into seconds. What do you think we should do? What do you already know? Well, you know there are 60 seconds in a minute. So if I convert 7/12, let's go ahead and convert 7/12. So let's take 7/12. And what do I have to multiply by in order to turn this to 60, the denominator to 60? We're going to multiply by 5, right? So now you end up with 35 over 60, and that is 35 seconds. So the winner's time, so this is the answer right here. It's 31 minutes, 35 seconds. That is your answer. So this last little step right here, where you're converting your fraction into seconds, right there. The winner's time is 31 minutes, 35 seconds. So do you see now why I didn't use that little itty bitty spot? I used a separate piece of paper. All right, we're going to keep going. We're going to use a separate piece of paper again for problem number 2. John used 1 3/4 kilogram of salt to melt the ice on his sidewalk. Then he used another 3 4/5 kilogram on the driveway. If he originally bought 10 kilograms of salt, how much does he have left? So, what operation do you think we're going to be using? All right, think about that for a second. I want you to try to draw out a tape diagram to show John used 1 3/4 kilogram of salt to melt the ice on his sidewalk. Then he used another 3 4/5 kilogram on the driveway. And then he originally bought 10 kilograms of salt. How much does he have left? I want you to draw that out. I want you to show that to me. Go ahead and try it and then come back after you have your tape diagram drawn. Okay, so let's see what you did in comparison to what I'm going to do. Okay, since I know he bought 10 kilograms of salt, I'm going to draw a whole bar and label it 10 kilograms. So here is my bar, my tape diagram, and I'm going to label it 10 kilograms of salt. Now, he used some of the salt for sidewalk and some for the driveway. So I'll divide this up into 2 smaller parts inside the hole. So I'm going to draw 1 3/4 and 3 4/5. Now, what we don't know is how much he has left over, right? So how much salt does he have left over? How do we solve this problem? What is a way that you might solve this problem? Well, you could use the total of 10 kilograms of salt to subtract the 2 parts to find the leftover part, right? You could subtract and then subtract. You could also add up the 2 parts to make them a bigger part and then subtract it from the 10 kilograms, right? So what I want you to try to do is I want you to either decide, are you going to take 10 kilograms and subtract it one at a time to get your answer? Or are you going to take 10 kilograms and subtract it from a larger part to find the difference? So right now, what I want you to do is I'm going to give you 4 minutes to complete this problem and come back to check your work. Okay, so how I'm going to attempt this problem is I'm going to take 1 3/4 and add it to 3 4/5. So I'm going to take 1 3/4 and add it to 3 4/5. Now, I'm going to go ahead and pull out the holes, 1 plus 3, and I'm going to leave 3/4 and 4/5 in here to solve for. So I end up with 4 here. Now, what is my common denominator going to be? I'm going to multiply by 5, multiply by 4. If you have to scoreboard, of course. However you're more successful, that's what you want to do. So 15 plus 16 here is going to over 20. So I'm going to end up with 4. And 15 plus 16 is going to give me 31 over 20. 31 over 20. So what do I have to do? I have to pull out the whole, right? 20 over 20 plus, what's that going to give me? 11 20ths. So 4 plus 1 is 5 and 11 20ths. So what do I know so far now? I know he used up 5 and 11 20ths of his salt. So I need to take 5 and 11 20ths away from the total, right? So let's take 10 kilograms and subtract 5 and 11 20ths. So how am I going to do that? So let's go ahead and stack this. Let's say 10 and let's subtract 5 and 11 20ths using the standard form here. Now, you can't just bring down the 11 20ths. That is not okay. You have to borrow. You have to regroup and add 1 over here and have 20 over 20. Now you can actually subtract. So what is 20 subtract 11? It is 9. Bring down your denominator. 9 subtract 5 is 4. So 4 and 9 20ths kilogram of salt is left over. Now remember, this is the answer. All right, how did you do? Were you able to successfully solve that problem? I'm sure you did. Okay, so let's go on to problem 3, which is kind of a funny little problem. Sinister Stan stole 3 3/4 ounces of slime from Messy Molly, but his evil plans required 6 3/8 ounces of slime. He stole another 2 3/5 ounces from Rude Ralph. How much more slime does Sinister Stan need for his evil plan? All right. So how are you going to attempt this problem? What do we know? Well, we know how much his evil plans require, right? So we know the total, 6 3/8 of slime. We know that he stole a piece and a piece, and now we need to know how much is he still lacking. All right, so what are you going to do? I want you to draw this out. I want you to draw a tape diagram. Show me what you know. Show me the problem. What is it that you're solving for? And then come back and check your work. So I'm going to give you 3 minutes to decide how are you going to solve this problem. Draw it out. And then of course, attempt the problem independently and then come back and check your work. Here we go. All right, so do you have your tape diagram drawn out? And we know Sinister Stan needs 6 3/8 slime all together to create some sinister plan. Now, we know Sinister Stan stole 3 3/4 ounces from Messy Molly, and he stole another 2 3/5 ounces of slime from Rude Ralph. How much more slime does Sinister Stan need in order to meet his evil plans? So what are you going to do in order to solve this problem? Are you going to use the same strategy as you did on the last problem? Or are you going to, you can try this 2 different ways. You could subtract once, take that answer, and then subtract here. Or you could put these together and subtract this from here. So what are you going to do? Well, I think I'm going to say 3 3/4 plus 2 3/5, and then I'm going to subtract it from the whole. So here we go. I'm going to pull out 3 plus 2, and I'm going to leave 3/4 and 3/5 to put together. So I'm going to end up with 5. Yes, I'm going to change this to a common denominator. We have to scoreboard, of course. 15 plus, so 5 times 3 is 15, plus 12 over 20. What is that going to give me? That's going to give me 27 over 20. Now I have to pull out my whole number, 20 over 20 plus 7 over 20. So I'm going to add these two together. I'm going to get 6 and 7 20ths. So that's how much he stole. He stole this much. He stole this much slime. Now we need to know how much slime he still needs in order to create this crazy, sinister plan. So now we need to subtract this from here, correct? So let's come up here and let's use standard form and subtract these two from one another, 6 and 7 20ths. So he's almost there. So what are we going to change this to? What common denominator do you think this is going to be? I think I see 40 here. But if you need a scoreboard, of course. So I'm going to end up with 15 40ths and 14 40ths. So 6 subtract 6 is going to be 0. 15 subtract 14 is 1/40 of an ounce. So the answer is Sinister Stan needs 1/40 of an ounce of slime to complete his plan. That right there is your answer. All right, how did you do on that? All right, let's go to problem 4. Remember, these problems are going to be problems that you're going to see on the end of the module test. So if this is going well for you, excellent. If you need to rewatch the video, rewatch the video. All right, so here is problem 4. Problem 4. Gavin went to a bookstore with $20. He spent 9 3/4 of his money on a book and 3 4/5 on a poster. What fraction of his money did he have left? Write the answer in dollars and cents.